Hey there YouTube. In today's video we're going to be working on automotive AC system. Now automotive AC is one of those things that's kind of like voodoo to some people, but it's really quite simple. What we're going to be working on today is my 2001 Chevy Express van, high roof, 2500. It's got the 5.7 liter 350 Vortec in it, and this is a camper van conversion. I've had this van for roughly 4 to 5 months. I bought it this winter. I've done quite a bit of work to it. This van's a 2001. It's got over 1 million miles on it. I paid $800 for it. This van used to be a FedEx delivery van. The guy I bought it from used it for doing carpet installs, and it had a lot of minor issues with it. The exhaust had fallen off. It had a slight transmission issue. None of the doors open and close properly, and we fixed a lot of that stuff on it now, and come this spring it should have been no surprise that the AC is not working. Upon a visual inspection, the AC condenser core is quite beat up. It's coming apart on the bottom here. Also, this line that runs off of here's got a hole rubbed in it. So we've ordered those parts, as well as a new AC accumulator dryer. The AC pump's not seized up and it seems to feel pretty good. So hopefully once we get this system sealed up so it's not leaking again, everything should work properly. Here's what we have to fix this. We've got a new AC condenser, we've got our new line, we've got an accumulator dryer, and some 134A freon set of gauges, and I also have a vacuum pump, which I don't have over here right at the moment. Basically how an AC system works, it works on phase change. So when you take a compressed liquid and convert it into gas, that phase change draws heat out, making it cold. So when you have a closed loop system, it comes through the compressor, compresses it, which in turn is a byproduct, heats it. It then goes through your AC condenser to draw the heat out of that liquid, and it'll go through a restriction. Two common restrictors are either an expansion valve or an orifice tube. And what that does is it creates separation from the high pressure side to the low pressure side. Now when this fluid comes through at high pressure, it's a liquid form. It comes through that restriction, it expands and turns into a vapor, and that phase change draws the heat out and makes it cold, which then will run through another, basically a radiator, and your fan will push through that, and that will be cold because the liquid has gone from a liquid to a vapor, dropped in temperature, and now that essentially radiator is going to be ice cold, pushes the air through it, and you get cold air in the cab. It then comes out of that into the low pressure side of the compressor, gets recompressed into liquid form again. The heat's then drawn out of the liquid, and it just keeps repeating that cycle. So once you understand how something works, it's a lot easier to diagnose how to fix it. Basically, you know what needs to happen in order for it to work. You can figure out why it's not working. In this case, the system won't hold freon, and it's a closed loop system. So we're going to fix that, and then we'll pull a vacuum on the system, make sure that we don't have any leaks, then we'll go ahead and charge it up and make sure that everything's working properly. Now, if we get it all back together and we find that the high pressure side is spiking and you don't have anything on the low pressure side, that would indicate that you need to replace the expansion valve or orifice tube, that it's been plugged. But we can't really test that quite yet, because the first thing we need to do is make the system a closed loop, because right now anything you put in, it's just going to come out. So let's get to it. Now before we change out the receiver dryer, we're going to go ahead and pull a vacuum on the system here. Check it for leaks. So we ran the vacuum pump for a while, got it down to 20 inches of mercury, shut our valves off, then we waited about 20 minutes and it hasn't moved yet. So I feel pretty confident that the system no longer has any leaks. We can go ahead and change out the receiver dryer. I wanted to make sure I tested the system for leaks before I changed that because the receiver dryer contains a desiccant. And the longer that it's exposed to the moisture after you remove these caps, the less effective this receiver dryer is going to be. So I wanted to make sure that I didn't have any leaks in the system before I installed this. So we've got our new receiver dryer installed. Been pulling a vacuum on it here for a while. To check if you're having trouble holding a vacuum is sometimes your connections here aren't sealed quite right. And you gotta kind of wiggle them and get them to seal. But now that we've got 20 inches of mercury on here, vacuum pump's been running for 20-30 minutes. Pretty safe to say all the moisture is removed. I'm going to go ahead and shut these valves down. They're turned off. Turn off our vacuum pump. We're going to let it sit for a good 15-20 minutes to make sure that this needle doesn't move. Okay, now it's been about 20 minutes. You can see the needle hasn't moved, so our system's completely sealed. We can go ahead and remove the vacuum pump. Now if you look at this label here, it says front only, 3 pounds 0 ounces of refrigerant, front and rear 4 pounds 8 ounces. Ideally what you would do is you'd set your freon on a scale and measure it, or if you use the cans you can use the weight on the cans to add up to 3 pounds. I normally just charge off of the pressure readings on my gauges, which isn't 100% accurate, but it's always worked well for me. But ideally you would measure the amount and match it to what your label says on your AC system. Now also, because we replaced some components, we replaced the AC condenser, the receiver dryer, and one of the lines, you know, all those parts would have contained some refrigerant oil, so we're going to need to replace that. Fortunately, there's not really a good way to measure how much oil you lost in changing the parts, so you just kind of got to wing it. You know, I'd probably for this I'd add about 1 ounce. And so what we're going to do is I'm going to take the cap off of this, just kind of put this over the top, turn it upside down, open the valve and the vacuum in the system. We'll draw some of my refrigerant oil in, and then when I charge the system with freon, it'll push all that through and get into the system. So that's how we're going to do that. Okay, so now we've sucked our oil in. Got our gauges, both of our valves are closed. We've got our freon hooked up with our bottle nut adapter. Just gonna turn this on. Don't see any leaks. Go ahead and turn your bottle upside down so you're injecting liquid freon. And you can go ahead open both of your valves. Generally, I'll wait till it basically stops flowing in. You can see our bottle pressure is about a little over 60 pounds. So we're just let this sit for a minute with liquid freon going in till it equalizes, and we'll shut our valves down. We'll go ahead and start up the engine, turn the AC on, and that should be enough to get the compressor to kick on. And at that point, we'll have both of our valves shut, and then we're just add in from the low pressure side until I'm happy with what the gauge readings are. Now that the fan clutch is kicked on, we're actually running fairly low on the high pressure side. Low pressure side's running right about where I want it to. It's actually a fairly cool day out today. I'd much rather have it be undercharged versus overcharged, so I think we're going to leave it there for right now. Check and make sure that we got good cold air coming out of the vents. It's definitely very nice cold air coming out of the vents here. So everything's working as it should. Obviously, if you actually measure the amount of freon that you're putting in it, takes a lot of the guesswork out. Generally, your pressures, if you're going to do it off pressure, your pressures are going to read a little bit lower on a cooler day than they will on a hot day. So if you're working on your AC and it's actually kind of cool out like it is today, you will want to err on the side of caution not to overcharge it. And you can always go back and recheck it later. So anyway guys, I hope you enjoyed this video. Be sure to like, comment, subscribe down below. Thanks. Have a good day.